Okay, now what we're going to talk about are what are called polynomial functions and graphs. Polynomials, we've actually already been doing polynomials because quadratics are polynomials and linear functions are also polynomial functions. But what we're doing here is we're going to talk about polynomial functions and graphs, sort of a more generalized example. Linears are very specific polynomials. Quadratics are specific polynomials. Now we're going to go into a generalized kind of function that we just refer to as polynomials. There are two forms that a polynomial function can take, and what we're going to look at first here is this is the standard form of a polynomial, and then what we're going to look at after that is what's called the factored form of a polynomial. We did briefly look at the factored form of a quadratic in the previous lessons on quadratic functions. Okay, so I know this is very confusing looking. You don't have to memorize this. This is sort of a technical way of writing the standard form of a polynomial function. Basically, what you have is you can have any power on x to the anything power. That's why we put n. And then typically the way we write it is we'll have something times x to some power, like the 73rd power, plus something times x to the 72nd power, then the 71st power. Then they'll keep going down, the 70th power, 69, 68, 67, 66, eventually until you get to x squared, then x to the first, and then the very last term is a constant. And we saw that when we did quadratics. I want to show you some examples of standard form of a polynomial function. F of x equals 2x plus 5. This is a linear function. It's also a polynomial. Okay. F of x is equal to x squared plus 3x minus 28. This is a quadratic, but it's also a polynomial. This is now what we call higher power polynomials or higher order polynomials. So we have f of x is equal to negative 7x to the third power plus 6x to the second power plus x to the first power minus 3. And so when we get to the third power of polynomials, that's when we really start to call them polynomial functions, okay? But the key here is this, is that it's always x to some numerical power. You're not going to have some number to the x power. That's an exponential function. You're not going to have, something over x like a fraction, but you can have fractions. You just can't have x in the denominator, okay? Here's another example of a polynomial function, 5x to the 17th power minus 8x to the 10th power plus 4x. And this is x to the first power. Now notice we skipped a bunch of powers. We don't have x to the 15th or the 16th or the 14th, and that's okay. It'll still be a polynomial function even if you skip over powers. Okay. It also doesn't have to have a constant. Some polynomials don't have constants at all. For example, f of x equals 3x. That's a polynomial. F of x equals x squared. That's a polynomial. F of x equals x cubed minus 5. Also a polynomial. And then f of x equals 32x to the fifth power minus 1. Okay, these are all examples of polynomials because they all have x to some numerical power. And then we start with larger powers and we go down to smaller powers and then we end with a constant. Okay, now let's talk about the factored form of a polynomial function. Again, here's a general form. It's a little confusing looking, but notice what we have. We'll typically have maybe a number at the beginning, which we'll call a, just like in a quadratic function. And then we'll have an x minus a number times x minus a number times x minus a number, all the way down to x minus another number. And so basically what we do is we break the polynomial into a whole bunch of binomials. Notice these are all x to the first power. X to the first power minus a number. X to the first power minus a number. X to the first power minus a number. Okay. You can have x to other powers inside these, but then they're not generally considered binomial factors. And it wouldn't necessarily be called factored form, although it probably can. anyways. So here are some examples of factored form. We have negative 3 times x minus 7. You'll recognize this maybe from the point slope form of a line. And so point slope form of a line is actually written in factored form of a polynomial. And then here we have the factored form of a quadratic, x plus 6 times x minus 8. This one I wrote twice. I wrote in two ways because I want to show you how factored form can work sometimes. We have 4 times x minus 1 times x plus 2 times another x plus 2 times another x plus 2. So you can have the same factor more than one time in factored form. But what we typically do is we group together all the ones that are identical, and we put an exponent on it. So this is still factored form. We have 4 times x minus 1 times x plus 2 cubed, which might remind you of vertex form. So remember vertex form of a quadratic, we might have f of x equals 2 times x minus 5 squared plus 3. Okay, this is basically factored form. What we're doing is we're taking a quadratic and we're squeezing it into a factored form. Okay, and then here's another example. F of x is equal to 2/3. This is our a, 2/3, and we can have fractions as long as they don't have x's in the denominator. 2/3 times x minus 3 to the 7th power. That means that there's 7 of these. There's 7 x minus 3's. And then times x plus 8 to the 11th power. That means there's 11 x plus 8's. And in all, so if we said, how many factors are there? Well, there's one factor here. Here there's 2 factors. Here there's 1, 2, 3, 4 factors. And here there's 7 factors plus 11 factors. That's an important concept. The number of factors is called the degree. And so there are 7 factors plus 11 factors for a total of 18 factors. And so the degree of this polynomial is 18. But we'll get to degree in the next video, or maybe the one after that. All right, so here's a couple words we'll use sometimes. When converting between standard form and factored form, if we're going from standard form into factor form, we call it factoring. So when we go from a standard form quadratic into a factored form quadratic, we call that factoring. We can also go from a third power polynomial, see third power right here, we would call it a third degree polynomial, into 3 factors. Look, x times x times x is x to the 3rd power. And so typically, however, whatever the power is of your polynomial, that's typically how many factors you'll have usually. And so when we convert from the standard form into 3 factors, that's called factoring. We can also go from factored form into standard form. When we do that, one word we can use for that is called distributing. So we're distributing x times x is x squared. 3 times negative 6 is 18. X times negative 6 is negative 6x. 3 times x is plus 3x. When you add them together, you get negative 3x. You've done this before. And so that's what it's called. It's called distributing. We can also take a 3-factor polynomial, and we can distribute, and we would wind up with a 3rd power polynomial. And now one of the things that we're going to look at is the graphs of polynomials. And one of the things that's important is you have to be able to distinguish between the graph of a polynomial and the graph of something that is not a polynomial. And there's one main way, well, 2 main ways. There are 2 things that you can notice about polynomials that are not true about non-polynomials. The first thing is that the sides, when they go to negative infinity, they always go up or down. Okay, see, that one's going up and this one's going down. This one's going down, this one's going up. This one's going up on one side and it's going up on the other side. This one over here is going down on the left and down on the right. And that's typically what we'll say is we have the left and we have the right. And we'll say, well, on the left, this one's going up, and on the right, this one's going down. On this one, on the left, it's going down, and on the right, it's going up. On this one, on the left, it's going up, and on the right, it's also going up. Okay. But on non-polynomials, I want you to notice that when we go off to the right and off to the left, this one is not going up or down, it's going sideways. And when a graph goes basically directly sideways, it's not a polynomial. Okay, here's another one that's going sideways off the graph. It's definitely not a polynomial. Okay, the other thing is this is polynomials don't have a break. Do you see this break right here where the graph is broken apart? Polynomial graphs stay together. They don't have any breaks in them. They're continuous. They just stay together the whole time with no breaks. Okay. The other thing is this is polynomial graphs are smooth. They're curvy. They're not sharp. They don't have any angles. Okay. Do you see over here this one? This one has an angle. Even though it goes up on the right and up on the left, the problem here is this sharp point. There are no sharp points in polynomials. All of the points on a polynomial are smooth and curvy. Okay. All right, well, that's our introduction to polynomials, and we'll move on now to some more specific information.